Hello, I am Dr. Baldwin Immanuel, working as Associate Professor in the Department of Electrical and Electronics Engineering, Amet University. Actually, today I am going to discuss about the topic types of electric circuits. In the types of electric circuits, we generally work on circuits. We know that if we are going to establish a circuit, the appliance will work. For example, if you see, we have fan over here, we have tube light, we have projectors, and all the things works on electricity. And if the switch is on, the light will be on. See here, the tube light is on because the switch is on. Here the fan is off because the switch corresponding to the fan is switched off. That's a general thing which we will be knowing. But today we will be seeing that what are the types of circuits which have been available and what are the types are needed to operate a circuit. That we will be seeing it one by one clearly. As we saw in the slide, the types of circuits, we have 4 types of circuit. The first one is open circuit, second one is closed circuit, third one is short circuit, and the fourth one is earth circuit. We will be seeing one by one clearly. What is open circuit? Open circuit is, for example, we have a circuit. We know that current will be flowing in any electrical circuit if the potential difference or the EMF is being applied over there. But still there is one more condition, that if there is only closed path, then only current will be flowing. I will be drawing a simple diagram so that it will be easy for you to understand the things. See, the simple circuit I will be drawing will be having phase and neutral. We know that electricity will be flowing only in a closed path, and we need, if for a single phase supply, we need 2 wires. One is phase wire and the second one is the neutral wire. This will be connected across a supply of 230 volt, 50 hertz AC supply. Okay. Therefore, across this we will be connecting the circuit which we need to be connected. For example, first we will be having the fuse for protection, then we will be having a switch, and then we will be having the appliance, the load which we are going to control. Here for the examples, for this simple circuit, I am having a lamp L1 as the load and I have a switch S1. Okay. Therefore, a simple circuit which tells that with the help of the single phase supply, a protection 5 amp fuse is being connected to the circuit and a switch and the lamp which has to be controlled. If the switch is closed, the lamp will glow. Okay. If the switch is open, then at that instant the lamp will be open condition or off condition. The example which I told you earlier, this fan which is been available over here is not running because the switch is being opened. Okay. Therefore, this will be a example of open circuit. Daily in our routine life, we have 2 circuits which will be operated. One is open circuit and second one is closed circuit. In the open circuit condition, current will not flow through the circuit. Okay. Therefore, at that time my appliances, electrical appliances, whatever be the appliances will not work. The second circuit is closed circuit. That is a circuit, for example, the tube light which we have over here. The tube light is been on. Why? Because the switch is been on. That means here the switch S1 is closed. When switch S1 is closed, current will be flowing from phase to neutral and the lamp will be getting the supply and lamp will be glowing. This is an example of second circuit which is closed circuit. The third one is short circuit. What is short circuit? See, the shortest path. We have generally the circuits where we normally use. For example, I'm coming from a place which is some 10 kilometers away from this location. If that is the case, regularly I will be using a route. Okay. If there is a traffic, what will I do? or if there is a new route which is being created, what will happen? Will I choose the regular route or I will be going for the new route? If that is the case, I will be sitting and I will be thinking that which is the shortest path. I will be going for the shortest path. Likewise, the current will also see for the shortest path. For example, if there is a wire which connects the phase and neutral like this, we know that supply will be flowing from phase to neutral. But if this is a thing, this will be having a resistance of R is equal to 0 ohms. But your lamp will be having some resistance. But compared to the lamp resistance, this resistance is very less. Therefore, current will be taking the shortest path. This will be called as short circuit. In this situation, my lamp will not get the supply. My lamp will not get the supply. Supply will be short circuited. And we all know that current, according to the Ohm's law, I is equal to V by R. If this resistance is 0, V by 0 will be equal to infinity. Okay. Therefore, current goes to infinity. In a short circuit, current goes to infinity. And this is an example of short circuit. Wherever we develop a circuit, if short circuit happens, it's not the thing that we are making a short circuit. For example, if this is a metal part, if this has been lying over here, or a bare wire which connects over here, phase and neutral, it makes a short circuit. In that situation, my load or my appliances will not get the actual power. Okay, because of this short circuit, my current value will be very high, which will damage the circuit. If you have equipment like fuse, then that fuse will blow out. Okay, the fourth one, we'll see the last circuit, which is the earth circuit. See, the same circuit, I'm not mentioning the lamp load, I'm generalizing the load as electrical load, some load, electrical load. Therefore, here the circuit will be closed, but in the earth circuit, I will be connecting the body of the appliance to the ground. Why this earth circuit must be done? See, for many of us have been experienced the condition of shock. Why do we get shock? Shock is nothing but the current or the excess current or the current which has been coming in contact with the body of the appliance, it takes a closed path. Okay, how the closed path is being made? This closed path will be made with the help of our body. Our body has some resistance. Okay, therefore, for example, if this is an appliance and the body of the appliance is having the current because of some loose connection, in that case, if I am going to touch this appliance, then a closed path will be made by my body. Since my resistance is less, current will be choosing the shortest path and I will be getting the current flow. This is a case of the earth fault, that is the shock, as well as this must be avoided. For avoiding this, we are going for the fourth circuit, which is called as the earth circuit. If earth circuit is being made, for example, we have 3-pin sockets. Generally in the houses, if you see, we have the 3 pins, the phase, neutral and the earth pin. This earth pin will be making the earth circuit. This earth pin, if you see, the back side of the earth pin will be connected to the earth with the help of a thick wire. This is being done, why? Because the wire should not melt during the faulty condition. If that is the case, this appliance will be connected with the earth circuit like this. The third pin or the body of the appliance will be directly connected to the earth circuit, which has a resistance of R is equal to 0 ohm. If that is the case, if a fault occurs in the appliance during the faulty condition, that is, if a bare wire comes in contact with the appliance body, at that time the current will be flowing to the earth circuit. If the current is being flowing through the earth circuit, then at that time if you see resistance is 0, what will be the current value? I will be equal to V by R, where V by R is 0, which is equal to infinite. Current will start rising to infinite within a short span of time. If that is the case, your fuse rating which you have done is 5 amp. The current will exceed the 5 amp, which will make your fuse to blow out. If your fuse is being blown out, automatically my circuit will be coming to the first case, which is the open circuit. Open circuit, we know that current will not be flowing through the circuit. That means my equipment is being protected, and I am also protected from getting shock. I will not be getting shock, and my equipment is also being protected because of that. Okay, this is the types. First one is open circuit, second one is closed circuit, third one is short circuit, and the fourth one is earth circuit. And I want to further go into the closed circuit. In the closed circuit, we will be having two types of circuits. What are they? One is series connection and the second one is parallel connection. Series and the second one is parallel. Okay, what is series connection and what is parallel connection? Because we use circuits, we tell that current will be flowing through a closed circuit, we know that, and a simple diagram I have drawn and I have explained you. And in the houses or in the workplaces, we use fan, AC, then mixies, grinder, lights, projector, laptops, system, everything will be connected with the help of electrical supply, and we will be using the circuit which is closed when we are using, and it will be open condition when we are not going to use it. Now in the closed circuit, how the current will be flowing? What are the types of circuits which have been available? If that is the case, we have two types of circuit. One is series circuit, second one is parallel circuit. Then we will be seeing what is series circuit. See, for example, I have two equipments or two resistance. Mention it as resistance R1 and resistance R2. How they are connected? The symbol of resistance is like this, and how they are being connected. This can be a load also. See, for example, the lamp load which we use is also a resistive load. Therefore, two lamps, that means electrical appliances. Okay, two lamps, how they are being connected? See, at the same time we are using some 10-15 tube lights. We are using some 10-15 fan, as well as some systems are being used, but at the same time it's been controlled separately. Individually it is being controlled. Then what is the type of circuit which we are using? At the same time, if you see over here also, all the fans are being off, switched off, but the lights are being on, projector is on. Then how the system works? Then what is the type of connections? If you see, we have two types of connections, series connection and parallel connection. Therefore, two loads, one I am mentioning it as R1, the second one I am mentioning it as R2. How they are being connected? And I have the power supply. Okay, it may be AC power supply or DC power supply, whatever it may be. For example, we can take it as, for simple consideration, we will be taking it as DC power supply. Okay, therefore it is a DC battery or a source. I have resistance R1, I have resistance R2. How I need to connect, or in which manner if I am going to connect, it will be helpful for me. See, if I want to control the circuit, I need a switch for controlling the circuit. Therefore, I can have a switch so that it will be easy for me to control the electrical appliances. The battery or a DC source which is being connected in series with the switch. Now, how can I connect the resistance or the load which I have? I can connect it in series. If I am going to connect it in series, I have to note down that all the appliances which I have will be having two terminals. One is starting terminal and other one is ending terminal. See, the first element ending terminal will be connected to the starting point of the second terminal. Okay, the second element, the ending terminal is being connected to the starting point of the next element. Likewise, the switch will be connected with the starting point of the first element. If this is a connection, this is being connected in series, one after the another, one after the another. That means series connection. In series connection, the elements are connected in series. Therefore, current, if the switch is being closed, switch S1 is being closed, the current will be flowing through the whole circuit. If you see the current here, if the current is I, then at this junction also the current will be I, at this point also the current will be I. That means if the circuit is being connected in series, then current will be same. Current will not change in case of a series connection. Okay. And second point which has to be noted is, see, for example, if this load is been damaged, or it has been removed, or it has been defect, open circuited. Okay, if that is the case, if you see, the current may flow, but here there is a open. Therefore, we will be seeing the types of circuit. The first one is open circuit. That means in an open circuit, current will not flow. That means, sir, I have the resistance R2 or I have the load R2 where it's everything is okay. I have the battery, I have the switch which is connected in closed condition. I have the resistance or the load which I need to be operated, but current will not flow through the appliance. Therefore, in series circuit, if any one appliance is being damaged, then current will not flow to any circuit or entire circuit. Entire circuit will be open circuited. Okay. Therefore, this is a thing which we have to see. The second one, we have to see what is the voltage value. We saw that in a series circuit, current is same. Now, we have to know what is the voltage value. If we want to know the voltage value, I will be assuming the resistance 1 as 10 ohm. I will be assuming the resistance value 2 as 20 ohm. If 30 volt battery is being connected, if 30 volt battery is being connected, I know for sure this total voltage will be 30 volts. Is it right? This total voltage will be 30 volt because I know that battery voltage is 30 volt. This 30 volt will be divided in some formula or with some parameters for the resistance, because we have two resistance. Therefore, this is V1 and the next one is V2. Okay. Therefore, we can easily derive that total voltage V will be equal to V1 plus V2. Okay. According to the Ohm's law, we know that V is equal to I into R. Therefore, I can write it as I into R, total resistance. This is total resistance. Therefore, R equivalent or R total. I can write it as R total. Okay. V1 means it's connected across resistance R1. I told you that current remains same in case of a series circuit. Therefore, I, but V1 correspond to R1. Therefore, I into R1 plus the V is equal to I into R. Then that means V2 is equal to the current is I. Okay. Therefore, current is I, R is R2. Okay. This can be further reduced. RT total is equal to, here in the both the terms I is common. Therefore, I can remove I and take it as common, R1 plus R2. See, for in the LHS as well as in the RHS I have I can cancel it. Therefore, R total or R equivalent will be equal to R1 plus R2. Okay. Therefore, this is the total resistance and V is equal to V1 plus V2. I can be easily found out by I is equal to B by R equivalent or R total. Here in this equation, R total is equal to R1 plus R2. What is R1? 10 ohm. What is R2? 20 ohm. That means what is R total? R total will be equal to 10 plus 20, which is equal to 30 ohms. Okay, and I know that I is equal to V by R total. What is V? 30 volt. Divide by 30 ohm. What is the current? 1 amps. Okay, therefore the total current which has been flowing through the circuit will be 1 amp. This current is flowing through R1 as well as R2. That means once again from this equation I will be finding out the voltage V1. V1 can be found out by V1 is equal to I into R1, which is equal to 1 into R1 is 10 ohm, which is equal to 10 volt, and V2 will be equal to I into R2, which is equal to 1 into 20, which is equal to 20 volt. Therefore, this voltage 30 volt will be divided into B1 is equal to 10 volt and V2 will be equal to 20 volt. Okay. Therefore, 10 and 20 voltage, the total applied voltage is 30 volt, but across resistance R1 or load R1 is 10 volt. For across resistance R2 or load R2, the voltage is 20 volt. Okay, altogether 30 volt, but the voltage remains the same for series circuit. In a series circuit, which you have to notice is current will be same for all the equipments, voltage will be different. Okay, and one more thing you have to notice that series circuit, if any one equipment fails, all the equipments will be detached from the circuit, or none of the equipment will get the power. Third one, the equipments will be connected one after the other. This is a series circuit, and I'll tell you a best example. The example will be the decorative lights or serial set which we use for festival seasons, okay, or some marriage functions. We use serial set where some 20-30 lights will be connected in series. If you are going to remove any one lamp, then all the lamp will be going off, none of the lamp will glow. Okay, that's an example of series connection. Next I will be explaining you about the parallel connection. See, the same resistance, I have two resistance or two loads. One is R1 and the second load I am telling it as R2. So similarly, I have a switch for connecting the equipment. If this switch is closed, current will flow. That is my assumption. I have the same battery. I'll assume the same voltage, or same resistance also, 10 ohm, and R2 is 20 ohm. Okay, now in parallel circuit, how the resistance are being connected. See, in series circuit we saw that all the equipments are connected one after the other, but in case of the parallel circuit, it will be connected in parallelly. That means, see, the starting terminal of first element, ending terminal of first element, starting terminal of second element, ending terminal of second element. I will be connecting all the starting terminals together. I will be connecting all the ending terminals together to the supply voltage. Okay, you can have a lengthy one so that it will be easy for us to visualize. Okay, I have a switch S1, I have a battery source of 30 volt, and I have two loads R1 and R2. See, this will be the diagram for parallel connection. Here two resistance or two electrical equipments are being connected parallel to each other. See, in the previous case we saw the currents have been same, but here if you see the 30 volt power supply is being applied over here, is it right? Across the battery I am going to connect it. See, across the battery I am connecting 30 volt, but if you see the resistance, this is the voltage across the resistance R1. Okay, similarly this is the voltage across resistance R2. That means in parallel circuit voltage remains same. For all the appliances voltage will be same. Whatever be the voltage which you are going to connect it, the same voltage will be appeared across R1 as well as R2. Okay, for separate operation, for example, I want to control the lamps or the loads individually, or if that is the case, instead of connecting the switch over here, I can connect individual switches for each lamps. See, I can connect individual switches, which I will be telling it as S1 switch S1, which has been connected in series with the resistance or the load R1. I can connect switch S2, which will be connecting in series with the load R2. Okay, therefore if I am going to switch S1, this lamp or this load R1 load will be getting the power. If I am going to switch S2, this R2 will be getting the power. If I am going to switch both the switches S1 as well as S2, then lamp 1 or the load 1 and load 2 will be getting the power. Okay, this is an example of the connection which we have in present household wiring, or in the house, in the hospital or office, wherever we have this wiring only. See, we use different switches, we use different equipments, and all the equipments which we have will be operated with the help of 230 volt AC supply. Okay, therefore voltage remains the same. We will be switching on and we will be working the appliances. Okay, now we will see what will be the current value. Now we saw that voltage remains same. Okay, what will be the current? If I is the current which has been flowing for the whole circuit, I1 will be the current which will be flowing for resistance R1, and I2 will be the current which will be flowing for resistance R2 or equipment R2, because at this junction current gets divided. See, the total current I is entering and it's been divided into two, I1 and I2, and at this junction if you see, once again this I2 as well as I1 will be merging and the total current I will be receiving over here. Therefore, if you have a ammeter to be connected over here, this will be measuring the total current. If you have a ammeter which is being connected in series with the load R1, then it will be measuring I1 current. If you have a ammeter to be connected in series with the load R2, then it will be measuring the current I2. Okay, therefore there is a case, and we will see what will be the current. Okay, here also I will be using the formula of the Ohm's law. I is equal to V by R, and here at this junction I told you that current entering, I is the current entering which is equal to current leaving. What are the currents leaving? I1 and I2 are the currents which are being leaving. Okay, according to the Ohm's law, I is equal to V by R. Okay, V divided by R. This V is total, or it can be called as V, sorry, I is equal to V by R, V total voltage. But we know that the voltage in a parallel circuit is same. Therefore, we don't need to have this total. This resistance will be total or equivalent resistance. We can write it as total resistance or equivalent resistance, which will be equal to, for I1 voltage remains same, that for same voltage, what will be the resistance? What will be resistance I1? R1 will be the resistance. Okay, therefore for current I2 it will be V by R2. We can simplify V by R total or R equivalent will be equal to we can take V as common, 1 by R1 plus 1 by R2. Okay, therefore V get cancelled. 1 by R total or R equivalent will be equal to 1 by R1 plus 1 by R2. Okay, this will be the R equivalent, that is equivalent resistance, the formula for finding the equivalent resistance, and we know that current is not same, current I is equal to I1 plus I2. Okay, therefore by substituting it, by finding the equivalent resistance, you can easily find what is the total current. Okay, using this formula you have to find R total. Okay, for finding R total or R equivalent will be equal to, what will be the formula? R1 R2 by R1 plus R2. Okay, R1 is, we know that it is 10 ohm, R2 is 20 ohm, therefore 10 plus 20, what is the value? 10 into 20 is 200, divided by 20 plus 10 is 30. What is the answer? Okay, this is 6.67 ohms. Okay, this 6.67 is the total resistance. Okay, therefore your voltage is 30 volt. For finding I, you can use the formula I is equal to V by R, which is equal to total, which is equal to V is 30 volt and the R is 6.67 ohms. You will be getting the total current. This current, if you are substituting it over here, then I1 and I2. Okay, for finding I1, you will be using 30 divided by 10. 30 divided by 10 is 3. Is that right? I1 is equal to 30 divided by 10, which is 3 amps. I2 will be equal to 30 volt divided by 20, which is be equal to 1.5 amps. Totally it will be 4. Therefore total current I will be equal to 4.5 amps. Here also you will be getting the 4.5 amps. That can be verified. Okay, therefore if you see, current is different. See, for I1 3 amp current is flowing, for I2 the current which is flowing is 1.5 amp. There is a big difference. Therefore in a parallel circuit, whatever be the current value, that's why we use AC, which has been of some high current value. We use low current value equipments also in series with the appliances. For seeing or for noticing the current value, we can easily see the thickness of the electrical wires. Okay, some wires we use is very thick, some wires we use is very thin. The thin wire which we use will be for low current applications. The thick wires which we use will be for high current applications. Therefore both the things can be connected only in a parallel circuit. This parallel circuit is the circuit which we use in household wiring circuit, office wiring, hospital wiring, whichever wiring we go. Normally we use parallel circuit. That's why we can have a separate lamp, separate switch for each lamp or equipments. I can switch off my fan, I can switch off my light, or whenever I need it I can switch it on. But in series circuit it cannot be done. This is the difference between the series circuit and parallel circuit. Thank you.